So let's start by taking a look at the operators on DX21. This is, unlike the DX7, this only has 4 operators, unlike the 6 operators of the DX7. And because of that, we have less algorithms for how we want to route the operators. So just as for a background, an operator on a DX synth is an oscillator, in this case sine wave oscillators solely, an envelope generator, and an associated amplifier, this kind of submodule. And the algorithms allow us to route and send signal from the various operators into one another or just out separately. And we can actually see that these kind of first 4 only have one carrier, which is our final output module for FM, and several, or in this case, a few different modulators, which are our modulating operators. I'm not going to get too much into FM synthesis because I'm more interested in how we program this instrument. But these 4 act as different ways to program a kind of single carrier algorithm. And then these other 4, we have different options for how to configure the operators as from multiple carriers. And there is a noticeable volume drop on this specific instrument for whatever reason. So the first 4 are kind of a higher volume, and as we get to the later ones, we'll see a sizable amplitude difference between the 2 of them. I'll try to accommodate for it. Anyway, so the different algorithms allow us to route something like, so we could have 2 operators as in series modulating the final carrier operator, so we can have the harmonics and the timbral FM modulation that we're getting from that will be almost infinite, or we can have them be in parallel where we just multiply the amount of harmonics. And some of these other, the later ones, we have similar options for that, but for like 5 and 6, they're giving us these frequency bands that we can actually use as formants because we have more than one carrier, but we can set the modulators up to modulate them all directly. So 6 would give us kind of these 3 frequency bands that we could use. And 7 and 8 are kind of more geared toward additive synthesis stuff. So we would have all 4, or in 7's case, 3 of them with one with a modulator that can act as more additive synthesis, and they're all acting as carriers. Anyway, let's get started with just looking at this synth. Right off the bat, we have A1 through 4 are how we turn the operators on and off, and you can see on the screen here we have these 1s, and as I press these buttons they'll turn to 0s, and that just turns the operator on or off. 0 for off, 1 for on. And the other thing we have is we have an operator output level control, which is B8. So the carriers, the operator output level for a carrier acts as a volume control. The operator output level for a modulator acts as more of a timbral control, even though for both modulators and carriers, the output level affects the amount of signal being passed through. It has a different role that it plays depending on whether an operator is a modulator or a carrier. So if I bring this down to 0, I'll turn all the other operators off. So we only are hearing operator 1. We're in algorithm 1. And so we're just hearing operator 1 as a carrier. And if I press the button, we're not hearing anything, even though the operator is on, because the output level is set at 0. As I bring the level up, we'll start hearing volume. Also, I should mention that the output level, there are some controls on the DX21 that happen in real time. This is not one of them, so I have to press the key continually for it to update. So I can I can slide through this data slider as much as I want, but it won't do anything until I update with a new key press. And we'll see the volume going up here, and we have our sine wave. So that is now we can hear our 1 operator, great. Moving on, to set what frequency it's at, there's a control B1, and we can see that this is set to 1. This just determines the ratio at which the operator oscillator, what frequency it's playing in relation to the note that I press. So if I play this note, we hear this, whatever frequency that is, and if I go down to, let's say, 0.5, we'll hear an octave lower. If I go up to 2, we'll hear the octave above that. The next control we have is a detune function, which doesn't do anything unless we have more than one operator on at a time. So let's do that. We'll go to let's switch our algorithm. So we'll go to algorithm 8 so we can hear two operators simultaneously. So we go to our algorithm select button, A5, and we can use the control to go up to algorithm 8. We'll turn on operator 2. We'll still hear our sine wave. I'll bring the volume up on that. But we need to hear operator 2, and to do that, we need to go to the output level. Now you notice here, this still says operator 1. This little screen portion tells us what operator we're controlling, because some of these controls, they control all the operators. They're not one-to-one. There's no one-to-one relationship for them. So we actually have to cycle through to the other operator, and that is done with this operator select button. You'll see the text operator select above this in purple. And so if I click that, it'll go to operator 2, and it'll toggle between operator 1 and 2. If I turn on operators 3 and 4, then it'll cycle through 1, 2, 3, 4, and it'll only go through whatever operators are turned on at the moment. So we see now operator 1 is on, operator 2 is not. We're at 0 volume for it. So I'm in algorithm 8, so we're not going to hear any modulation, but we'll hear another operator come in, one hopes. Let's see. So I'll bring up the volume for this. There we go. So we have our operator 2 and the frequency it's at. If we go to frequency ratio, it's actually at a frequency ratio of 1. And remember, we bumped up operator 1 to an octave above that. So now we're hearing these octaves. So we're hearing additive synthesis with one operator's oscillator at one frequency and one at the octave above that. If we want to detune these, actually let's go to, we'll go to operator 2 and we'll set them to the same frequency. And so now we're just getting operator 1 and 2 at the same frequency, and we just have more amplitude coming in. I can, if I go to operator 2 and I turn down the amplitude, we'll hear less, and if I bump that up, the two frequencies will just add together because of the same frequency. But if I wanted to detune them, let's see what happens if they're at the same frequency when I do that. We'll get this kind of amplitude modulation because they're set to the same frequency. So they're canceling in and out of each other. If I wanted to go to the frequency ratio and change operator 2 to double that so they're in octaves again, let's check the detune out. This will give us kind of a phasing effect. So now we're static, and it's not super obvious right now. Let's actually go to another algorithm. So I'll go to our algorithm select again, A5, and we'll go to algorithm 1. So this is a frequency modulation algorithm, and what we can do is I'm going to take out operator 2, and I'll turn off detuning. So this is what we'll hear as I bring the volume up from operator 2 going into, so 1 is a carrier and operator 2 is a modulator. So we'll hear as we're going from operator 2 into operator 1 is we'll hear, we have our sine wave, and we'll hear operator 2 modulating that and increasing the amount of harmonic content by adding sidebands to that sine wave. And I think that this is set so that operator 2 is at double the frequency, and this is like a typical way in FM synthesis to get a kind of quasi square wave, and you can see that. So that's our square wave, And we go back to our detune function, and I'll turn this up. And we can see that there's this kind of phasing as the operators are detuned slightly, and different frequencies are canceling each other out. And I can go to operator 1 and turn that, if I went plus 3 on operator 2, and I can go down the other way, and we'll actually get more detuned phasing, or a faster phasing. So this is kind of the most that we can get. I'm just going to add a lot of thickness to the sound here. I'll turn it off so you can see. And with it on again. So that can add a nice thickness to any sound. If we wanted to even, since we have our square wave, if we wanted to, just to give an example of adding even more modulators, we have a third one in series, so we can modulate operator 2 as a modulator already and add even more harmonic content to that. So I'll turn on operator 3, we'll go to the output level and go to our select. So we're now at operator 3 with an output level of 0. And let's see the frequency ratio. Let's set that to 2. So, or we can even set it above. We could set it double 2. So we're at 4, and we go to our output level. And if we go up, we can add even more content and make it an even brighter square wave. If we turn here, I'll turn it off for a second. So you can hear that it adds a brighter sound overall by modulating 2 with another operator. The last thing to show with the operators is feedback. So on every algorithm we have one operator, in this case operator 4, that allows for us to feed the output of itself back into itself. So I'll go to algorithm 8 because that's the only one that gives us direct access to operator 4. And we'll turn that on. We can turn the other operators off because we're just hearing 4 as its own carrier. And if I play, we're not getting any volume because I have to turn up the output level. And there we have our sine wave. And what we can do is we can go to the feedback control, A6, and turn that feedback up, and it will actually kind of create a kind of quasi-sawtooth wave as we do that. We have 8 degrees from 0 to 7. And the output level, because it's feeding back in, also has a timbral control. So if I turn this down, it can also smooth it out as well. Let me go back to 6. So that's pretty much it for the operators.